Hey, ladies and gentlemen, this is Miss Hemmert here. Sorry I couldn't be here today, so what I'm going to do is I'm going to quickly talk over your quiz review so that you feel ready for that quiz that you are about to take. Alright, so first off, let's take a look at number 1. So for number 1, it says that you are going to the Walker Art Museum with you or with your 7 friends. Only 3 more can fit in the car. How many different combinations of groups can you make? So remember when we were talking about combinations, that word group implies that order doesn't matter. So if order doesn't matter, then we're going to use a combination. So we have 7 and we're choosing 3 of them. Now here's that formula for combinations. Remember, you have 7 factorial, and then you're going to do the difference of the 2 factorial times that extra little part factorial. So then you end up getting 7 factorial divided by 4 factorial times 3 factorial. So remember that 4 factorial means 4 times 3 times 2 times 1. 3 factorial means 3 times 2 times 1, and so forth. So 4 factorial is the bigger factorial. So everything from 4 on down in 7 factorial is taken care of. So left up top you have 7 times 6 times 5. And then on the bottom you have 3 times 2 times 1. Well, when you multiply out 7 times 6 times 5, you get 210. Then you multiply 3 times 2 times 1, and you get 6. So then you're going to take 210 and divide it by 6, and that's going to give you 36 ways. Or sorry, 35 ways when you divide those two out. I do suggest you calculate along with the video so you make sure you're doing it right. Next, we're talking about a marathon with 7 other people. How many different arrangements are there for people to place first, second, or third? Well, if it's talking about first, second, or third, then the order does matter. So we're starting with 7 people, and we're going to put them in an order of only 3 of them. So in that case, order does matter. So on top, you're going to have 7 factorial, and on the bottom, you're going to have 7 minus 3 factorial. So then we have 7 factorial divided by 4 factorial. So then what we want to do is gonna cancel out everything from 4 on down in that 7 factorial. So left up top we have 7 times 6 times 5. And you multiply all of that out and you end up getting 210 ways. So there's 210 different ways that you can place in that race. Now let's take a look at number 3. Now we're going to talk about calculating probability. What is the probability of rolling an odd number on a fair die? So this is where we're just looking for 1. There's no or, there's no and. We're just looking for 1 probability. So first I want to figure out how many odd numbers there are on a dice. Well, there's 3, or 1, 3, and 5. So there's 3 odd numbers out of the 6 total. So that means there's 0.5. So there's a 50% chance of rolling an odd number on that dice. Now, let's take a look at number 4. What is the probability that you draw a queen or a 6? Well, if it is an or, that means we need to use a plus sign. If it says or, we need to use a plus sign. So I need to ask myself, is it mutually exclusive or is it inclusive? Well, can you be a queen and a 6? No. So it's mutually exclusive. So I'm only going to have 2 fractions that I'm adding together. So there's 52 total cards in the deck. How many of them are queens? 4 of them. And then there's still 52 total cards in the deck. How many of them are 6s? 4 again. So 4 plus 4 is 8 divided by 52. So you take 8 and you divide 52 and you get 0.15. So there's a 15% chance that you get a queen or a 6. Let's take a look at number 5. What is the probability that you draw a 5 or a club from a standard deck of cards? Again, that or, okay, I need to add. So I need to ask myself, can you be a 5 and a club? Why, yes, you can, because you have the 5 of clubs. So this one's inclusive, so we're going to have a piece that we need to subtract off. So first, let's calculate the probability of it being a 5. Well, there's 4 5s out of the deck of 52. What is the probability that it is a club? Well, a club is one of those 13 cards. Okay, so because it's one of those 13 cards, we need to do 13 out of the 52 because it's one of those suits. Then we need to subtract off the probability that it is a club and a 5. So that's 1 out of the 52. So we do 4 plus 13 minus 1, and that's going to be equal to 16 out of 52. And when you do 16 divided by 52, you end up getting 0.31. So there's a 31% chance of you getting a 5 or a club. Let's take a look at number 6. It says Miss Humbert really likes Reese's candy. She draws out the bin that has 6 Reese's, 4 utility candies. What is the probability that if she draws out candies, she gets all 3 Reese's? So in this case, this is kind of like an and probability. So if I draw a Reese's, and then another Reese's, and then another Reese's. So because that and is in there, we are going to multiply. And if I really like Reese's, if I take a Reese's out of the candy bin, I'm definitely going to eat it. So I start out the 14 total candies, and 6 of them are Reese's. And then I'm going to multiply. We're going to assume that whatever I take out of the bin is going to be a Reese's. And I'm going to eat it. So then we have 1 less total, and we also have 1 less Reese's. And then we're going to take out another piece of candy that we're going to assume is a Reese's. We're going to take out 1 less candy and 1 less total. So we're going to go ahead and multiply across the top. 6 times 5 times 4 is 120. And 14 times 13 times 12 is 2,184. Then you can go ahead and divide out that fraction. When you do that, you get 0.05. So there's a 5% chance that I draw out all Reese's when I'm drawing out that candy. Let's take a look at number 7. Mr. Yonker is letting his students take pets out of the cage. So he has 6 snakes, 2 of them sometimes bite. So if he has 6 and 2 of them sometimes bite, that means that 4 of them never bite. Once a student takes a snake out, they have to put them back. What is the probability the first 2 people get a non-biting snake and, okay, I need to multiply, the third person gets a biting snake? So to me, there's 3 students that are happening right now, and there's all multiplication. And another big important part is that they're putting them back. So because they're putting them back, the total doesn't change. Okay, so because they're putting them back, the total doesn't change. So we have 6 total snakes, and 4 of them don't bite. So the first person getting a non-biting snake is 4 out of 6. They're going to take the snake out, and they're going to put it back in. So then we're going to have 6 total again, and still 4 of them sometimes bite. Then the third person's going to come up, and they're still going to have 6 snakes because we put them back, but they might get a biting one, and that's only 2 out of the 6. So now remember that when we multiply fractions, we also multiply the bottom. So 4 times 4 times 2 is 32, and then when you multiply the bottom, 6 times 6 times 6 is 216. So you divide those out, and you get 0.15. Okay, so then you get 0.15. Let's take a look at number 8. We want to find the probability of drawing 2 spades without replacement. So we're talking about 2 things happening, drawing a spade and then drawing another spade. So to me, that implies multiplying. So we're going to start, and we have 52 total cards. And a spade is one of our suits, so 13 out of the 52. Then we're going to go down 1 more. And that's going to be 12 out of 51 because it says without replacement. So if I draw a spade, I'm going to set it aside. And so that means I have 1 less total, and I also have 1 less spade. So 13 times 12 is 156. And then you divide it, and you get 52 times 51, and that gives you 2,652. So you're going to take and you're going to divide 156 divided by 2,652, and you end up getting 0.06. So there's a 6% chance that you're going to draw 2 spades in a row. All right, number 9, find the probability of drawing 2 jacks with replacement. So again, I'm drawing a jack and then another jack. So this one right here is also going to be talking about multiplying. So I'm going to start off, and I have 4 jacks out of the 52. Now it says that I am replacing it. So I'm going to draw out that jack, and I'm going to put it back in. So I still have 52 total, and I still have 4 jacks. And now I'm going to multiply. So I'm going to take 4 times 4, which is 16, and I'm going to take 52 times 52, which is 2,704. You divide that out, and you get 0.01. So there's a 1% chance that you draw out 2 jacks. All right, let's take a look at number 10. So there are 2,400 subscribers to an internet service. 1,700 own HP, 1,000 own Dell, and 400 own both. what is the probability of getting HP or a del? So because it says or, I need to add. Now I notice that there's this both portion right here, which means if there's a both portion, that's something that I have to subtract off. So I'm going to have a fraction added to a fraction, and then I'm going to have to subtract off a piece because there is that both portion. So first let's find the probability of the person owning an HP. So there's 2,400 total computer owners. 1,700 of them own an HP. Next, let's find the probability that they own a Dell. So then we have 2,400 and 1,000 people own a Dell. Now we need to subtract off the probability of it being both. Well, our total is still 2,400, and then we want to put the probability that it's both, which is 450. So now going back to adding and subtracting fractions, our denominator is going to stay the same. The only thing we're going to add and subtract is our numerator. So we're going to take 1,700 plus 1,000 minus 450. And when you do that, you end up getting 20,250. So you're going to take 2,250 divided by 2,400, and then you get 0.94. So there's a 94% chance of that occurring. So that concludes your quiz review. You can go ahead and get your quiz once you are done. Please remember to make sure not to talk while everyone is quizzing. Thank you for listening.